Okay, if you've seen the last two videos on scale factor involving area, what we're going to do next is going to be quite intuitive and kind of make sense on the back of that. Okay, so again we've got that statement that we need. The two shapes below are similar, okay, and again we need that similar reference in there to be able to apply this mathematics. Again, we might not be able to see this perfectly, I'll go over this a wee bit, but we actually do have three-dimensional shapes here. Okay, we've got two cylinders. Just go over it so we can maybe see it a wee bit better. Okay, so again, the first step is the same as it always is, regardless of what type of enlargement or reduction we're dealing with. We need to work out whether it is a reduction or an enlargement. We can clearly see here that we've got the volume of the smaller cylinder, we want the volume of the bigger cylinder, so it's going to be an enlargement. So again, ESF at the site. Enlargement scale factor is big over small. Now you might be able to guess already what I'm going to have to do with the enlargement scale factor to make sure that I get the correct answer. When it was an area, we had to square the enlargement scale factor. When it's a volume, we have to cube it, okay? And again, that ties in with your units. If you think about any units attached to volume, it would be things like centimetres cubed, millimetres cubed. In this example, it's metres cubed. So it does tie in with the units, and obviously when you're finding a volume, it's three dimensions that you're multiplying together. So again, that's why we have to cube the enlargement scale factor to make sure it's correct. Again, I might have a calculator, I might not. If I don't have a calculator, then I definitely want to simplify this fraction to make things a bit easier for myself. So dividing top and bottom by 4, I'm going to get 5 over 2 cubed, not squared, cubed. Okay, from there, it's exactly what we've done before. We're just taking the volume, in this example we're multiplying it by the enlargement scale factor to get the bigger volume. So V equals 5 over 2, and we're cubing it, times 250, and that'll get us the volume that we want. And again, we're expecting a bigger volume here for the answer because it's a bigger cylinder. So again, you can use your fractions button to put 5 over 2 in and cube it, and then multiply it by 250. If you don't have a calculator that can do that easily, you can just do 5 divided by 2 equals, you should get 2.5. Cube your answer, which is 15.625, and then times that by 250. And we're getting 390, 6.25, and we're dealing in, I'm dealing in meters here, so that's fine, meters cubed. Okay. There is a wee change in units there, but because we have the same units as the height of the cylinder, the scale factor actually works, so that answer is actually fine and correct, even though we're dealing with meters cubed, but we're dealing with centimetres on as the height. Okay, and again we would expect a bigger volume, and that's what we've got.